Okay, I think I'm properly live. Yep, it seems like. All right. Awesome. Okay. Hmm. All right. Just a second. Um. Okay. Seems to be working fine. Okay. Um. All right. Turn this music down. All right. So basically, what I'm doing here is making a programming language, and it's gonna be a series. Obviously, I'm not gonna this today. I'm just making a scanner today. Should be like our details in the description or the about thing on Twitch. Yeah. First, start with just getting some basic like file input going. So we can you know, read a file in. Right. Mm-hmm. Okay. Okay. So we're gonna. What should I call it? Should I just call it that? Yois.rs? The name of the one is Yois, whatever. That doesn't really matter. But okay. So I have this this book that I was using to learn. Should be linked in description. And I like implemented like a like basic thing from it, and trying to look at that code and see how I should like, because I don't want to just copy it over, because the original thing was made in Java, and like I'm obviously coding in Rust, so I'm gonna like change up the structure a little bit so it's a little bit better suited. Um, so the thing is, it had a class for like the language, like a struct at least. Um, and the point of that was I would just like it was mostly just a bunch of functions together, but there was one variable that had to be kept track of but I think I can like pretty easily not worry about that if I what's the point of that? I think it's I believe it's mainly, what is the point of that actually? Like, cause it exits anyways. I guess get the right exit code. Oh, so it doesn't run the code maybe? No, it's not for that. I have no idea. That's weird. Oh, okay. So, does it matter anywhere else? At least it's it here. No, yeah. Okay. So when it errors from, say, the scanner, it reports that it's still matter. Okay. I guess what I can do with that is just start the run function. Okay, we're good. So yeah, what we're gonna do here is just make a bunch of functions. No struct needed. No struct or class needed. And check that my streams still going fine. Okay. Yep. All right, awesome. All right. So first of all, we're gonna need like a sort of like a, I'm gonna call it start, just a function to. Oh wait, what? Oh, okay, never mind. Yeah, just a function to sort of start off on. Like I've basically what I'm doing with the structure here is this is the main.rs. This gets compiled to an executable. This is the lib.rs. This gets compiled into a library file, right? And so like the point of separating them like that is okay, there isn't much of a point of separating them like that, other than it's just kind of cleaner. And what you can do then is use the same library for like a different executable thing. So you can just grab this out and it'll still compile. Just won't have an executable. It won't be able to be. Won't be executable, you know. Okay, I don't need to. Yeah. Okay. All right, so that's our little start function, and you're going to call it from our main. And also like sort of separate this like executable code so from this code. Oh, actually what I should do is probably not have the start function at all. And yeah. Get the args in our main function and then pass it on to some functions over here. Okay. Yeah. So let's just start doing that here then. So we're gonna be getting some args, so I'm using the standard IO result type. If you don't know what a result types are, if you haven't used Rust before, it's basically like stores like an error, but as just like normal as just like normal data, you know. It doesn't like, I'm not sure how to explain it. like usually in most programming languages, if you get if you, like type some code here and it gets an errors, that's just gonna like stop. You don't need to return the error from main, right? That's just gonna automatically stop the program there and print the error message. Well, here Rust doesn't have errors. Well, it kind of does. It does have the panic macro. Basically, this causes like a traditional style error. It's considered a very bad practice. So usually you want to return the error from main or like handle the error inside main or like inside some other function wherever the error appears. Usually you just like pass it up the chain to some, and eventually it would just get passed from main or handled. So yeah, and what this basically means is so there's a oh god, what the hell have I done? Okay, there we go. There's a normal like result type that's in like it's like preloaded. Probably this, yeah, normal result type. And basically what this is here is it's a generic, and what you can basically do is put the error type here. Actually, oh god. Okay. There's alright. That showed up on my on YouTube for some reason that very fun. So like I believe, let me check. Oh god damn it. Can you do that and also remove that because I'm not using panic? Does that not work then? So the type of either. Yeah, can I get the documentation please? Jesus. Oh my god. Okay. I believe that I can just check here actually. I can check here. I can't check here, I guess. Never mind. Okay, so basically, like it's let's assume the first value is the like the OK value, like if it doesn't error, and then if it errors, let's say if it doesn't error, you don't want to return anything. But if it does error, then you're gonna return a string. That's basically just like the message, the error message, right? That's that. And a lot of like specific operations like implement their own result type. It's basically just a type alias on top of that, so it's like type result type, like my result equals to like this, right? So then you can, or rather probably be like this. Wait, no. Like, you know, it's a type alias on top of that, so you only have to put in one value for what would be correct. Because like if you have a library and it has like specific errors, you make a result type for it. So that like error field right here is going to be like covered. That was way too long, so that does not matter at all. Alright, so we're gonna get our args from string.io. I'm just gonna copy this code over. It is. It's just very simple. So, okay. Getting the args. Right. And okay. This weird thing with our stars that you always get past the file name for some reason. I don't know why. Always do. One second, sorry. Yep. I always get past the file name as the first argument. I don't know why. It might be just a cargo run thing. Hello, Bobroth RTX. Oh yeah, that's an amazing user. Doing some coding here. Creating a scanner for a programming language. I have a better explanation in the description if you're interested. And I'm just trying to get a file input in here. So yeah, we're getting our R's right here, and I was just talking about how, like, in the rest of the language I'm using, like args just like it always like sends the file name as the first argument. I don't know why, but it does do that. So we're gonna have to do we're gonna check if actually sent us any args. So like usually this would be like if args.len is greater than 1, right? If that would make sense if there's one argument. But there's always one argument. It's this file name. I don't know. It's weird, but it happens. Okay. So here we run our code. Else, I believe we just print line or message. Maybe not that. Okay, it's fine, yeah. Usage. Oh, what do I want? I guess this, probably, yeah. Actually, God, I don't know this. I'm not great at command line stuff. But like, I don't know the standard stuff for them. I'm just gonna do square brackets. Actually, I'm just gonna do it. That makes more sense, right? File name? Or should it be a space or something? That's fine. This really doesn't matter. I can change it later, but yeah. I mean, it is good to like actually like consistent and follow standards, but whatever, it doesn't matter. Okay. Oh wait, oh no. I'm dumb. Equals to. Then we do our handling. Otherwise, we tell them that this is. I use the command. Right. And we're gonna pass in like a OK here. Basically means no error happened. See this? Yeah, makes sense now. Oh god, what did I do? Okay. Yeah, so it's just passing OK, and like the value for the OK is this. That's like the value you want to pass, right? It's wrapping OK as an enum, basically arithmetic type. Wrapped in OK, basically say the result is OK. I could return like error, and then well, that's not gonna work because the error type is not just void or the unit. I think this is called the unit type. So it basically means void. Yeah. Okay. I'm gonna make an FNMV file here. right? I think that makes sense, right? I'm gonna read file here, and then I do a run function here. Yeah, I think that makes sense. That makes sense to me. Okay. I'm kind of thinking I should, instead of just instead of doing the libdrs, I'll think about it. Let's do this first. Refile ring. Okay, so do I want to read like the file and return the string here, or do I just call the like the run or scan whatever function from inside here? I don't know. Okay, I'll call the scan function from inside here, and then I'll just like I don't know, like compile file. It's not gonna be a compiler for a while. It's gonna be just an interpreter to start, and probably a good bit. But let's call it compile file. Parts file. That's fine, right? That's like yeah, I think that's perfect. Okay. Okay. So then we get our file. So right, since this is another. Oh wait, oh this doesn't this is an error. Well, it could error here, but most probably will. You know, if it does, it will use the panic thing that I explained before. Right. Okay. So that doesn't actually error. We need this because this will potentially error. Do an OK here, so that it doesn't return anything. Then return OK. And I can copy code here. Okay, so mute means immutable, like you can change it because variables by default are immutable, like const, you know. And it's just basic code. So what this means here is this file returns result, right? And basically what this means is if it goes fine, then just get the value from inside and send it to the variable. If it does not go fine, then send the error message up to here. Right. Okay. So then we'll make a buffer for the contents of the file. Okay, yeah. Just simple buffer. And what we can do is file that. That. Why am I not getting autocomplete here? Concerning. Did I not? Oh, okay. Okay, I'm gonna hope this works then. Yeah. Yeah. Okay. String, and then we'll pass contents here. And oh god, that's annoying. I'm gonna have to do this here. Yeah. I don't know why it fixes it, but it does. Oh, that prelude for the result type though. It's not. I don't know why that fixes it, but it does. But whatever. Sure, man. And we have to reference it basically like a pointer. Okay. Right. So send that there, and then we can we're scanning here. Send to be parsed. Wrong order. Parsed. Right. So we're just gonna write that here. That's good to do, and yeah, sounds good. Okay. And then we're gonna go to libRs, and what I'm thinking now is I actually don't want to libRs, and instead we just want to go to straight to the scanner and stuff. And what we can do afterwards is like we can just replace this. Like it'll be easy enough. I just don't see like the like enough benefit there for me to actually bother with that. So oh, the result here should unwrap it. There we go. Oh, and let's do this real quick. How do we get the arg from inside? Arg under clone. Okay. Parse file. Args 1 dot 1. So we're getting 1 because unwrap that. Unwrap, right? Unwrap that. Oh, yeah, I'm gonna do that. So if it errored, I send it there. See how this, or if it errored, it's gonna send it there, and now I called this here, and if it errored, send it here, and see, we're just passing the error up to the chain until it either gets handled or returned from main. It's really cool. It's a really good system, I think. Definitely gonna use the same kind of system for this language. Okay, right. Okay. Yep, so we're doing args1 because as I said, for some reason it returns that it sends the file name as the first argument. I don't know why, but it does. So okay, so just to test it out, let's do a print line contents. Not contents. Right. Oh, I'm stupid. Right. There we go. And let's go to our terminal here. And it's going to be used the string. And do a quick cargo run. Oh, for it's gonna should give a uses JavaScript file name. That's really good. Okay, and then if I make a new file, call it like test src.ap. I think I'm gonna have my like file extension be JAP. I'll explain it some other time. I don't know, but that can change whenever. Random text here. Test underscore ftc. Right, no such file directory. I don't get why that happens. If I move it into there where the executable lies. Still no. I thought it would maybe work if I put it in the main directory because that's the directory I'm calling it from. Does not do that. What if I wait. Okay. So dumb. Okay, I guess it probably isn't it with quotation marks or anything. That source of txt guys. Oh, that JUP. That work? Nope. Okay, that did fix it. Okay, my suspicions were correct. It's your working directory that has to be relative to. That is. Oh, that's awesome. And also, it is args1 instead of arg0. Let's print arg0 real quick. Line. Arg0. Gonna let me do that, or drop a clone or something. No, I can just print. Okay. Yeah. Target debug queues. Probably because of, if I try // target debug right there. Yeah. And just whatever. No, it's still gonna same thing. I don't know. I don't know, man. Okay, that's whatever though. It's working. I'm very happy about. Right. So we're not gonna. Well, we're gonna leave print contents for now. We can remove that, and we can go into the actual scanner. All right. And I'll add something quickly scannable that later. So the scanner, that's not it. Our grammar is all these things. And for this language, like out of the main points is that everything should be implemented in code. Like pretty much everything should be implemented in code. Like there are not going to be any sort of no if statement, no while loop, none of that. Because you can access assembly directly. So you just implement it in assembly and create a function for it, and then program that function to use an if statement. Should be everything should be implemented in code. That's like the point of code. To make stuff, you know what I mean. Okay, that's like the whole point. So there's just like a few things and that allow like very basic literals, very basic literals. Oh, actually, what? Okay, so we want number literals and string literals and car literals, right? Character literals. What literals does this guy have? This string integer float. Okay. Yeah. And also function literals. Those are pretty fun. I think I got them pretty good. I think I made some pretty good syntax for that. This is the syntax. This is like the language itself, by the way. It's like the simplest code that you can like make without. And it says like, and it does barely anything because there's nothing here on like the basic level. It's not like completely basic though, because it does use some stuff from our core lib here. With the core lib. And the core lib is pretty essential. Like all the restrictors from the core lib will be used by the compiler itself. Will be used by the compiler, but they won't be like special in terms of. They won't actually be special. Like if you just create like a struct of like if you just create a struct like an object of type um, unless you actually if it's not like const then it's just absolutely useless. The compiler doesn't recognize it at all, you know, because it only uses types when they're const. Obviously you need to know types at comp time. So yeah, this stuff is like used by the compiler. This is in there. I really didn't want it to be in there, but I think it has to because of our number literals. Assuming the correlator, was really hoping I could just put in the standard lib. So this stuff is gonna like be like preloaded in there. Like you're not gonna have to do any scope resolution. Yeah, there's probably gonna be a lot more here too because another thing with languages metaprogramming. So there's gonna be a lot of stuff that the compiler uses, but is technically not at all special. And this stuff, if you're wondering why these are identifiers and not reserved symbols, these are all symbols. These are reserved identifiers. Usually reserved identifiers would be things like var, like while, like if, you know, but since we're not doing that at the language level, they're not here, but we do have this stuff. And so these are reserved identifiers. Like var is a reserved identifier because you can create a variable called variable, and just because it like starts with var doesn't mean it's gonna end up creating a var token here, right? Like here, if you did dot yibble, that would create a dot token and then this token. But if you did variable, to create a one variable token, not a var token and then a yibble token. Right? Oh god, someone hammering or something outside. It's annoying. Okay. And so basically, the thing with these is you'll be able to create identifiers with these. You can use any symbol for identifiers except these ones. These are reserved for symbols, can't use them for identifiers. And the reason is I could just put all of these in here, like, but the reason, oh wait, oh god. Okay, alright. For a second I thought I like messed something up real bad. You know, there's gonna be like two domains of identifiers, symbolic identifiers, which are these, and alphanumeric identifiers. And so like the point there is that you can make like an identifier that's like you can make an identifier from the plus symbol, and if you have um like a variable called x and a variable called y, these are both, all three of these are identifiers, but this is in a separate domain from these two because so that you can do this, right? If you did xy, that's not gonna be x and then y. It's gonna be xy. It's a separate identifier. But here, even though these are all three of these are identifiers, are like identifier characters, this is a separate domain, so it does not mix with these, right? Even though it's right next to them, these are in the same domain, so they do mix. And so you can do stuff like this. And yeah, so then we're able to have like this stuff, and not have it have you like have to have spaces in between and stuff, because they're in separate domains. But yeah, you can like we have the equal sign that's reserved for assignment, but you can make an equals function, like a function with this as the identifier. You can make that because it's not just equals, you know, it's the reserved identifier goes into the identifier thing. If you made a semicolon equals, that's gonna be a semicolon token, and then that token, right? What happened to the music for so long? I don't know. Probably an ad or something. Probably like a silent ad that I just did not fix. Sorry if you like the music. I think no one's watching. I'm pretty sure I'm not. If you're watching, I'm sorry. Yeah, that's fine. I'm gonna keep on talking though, in case I'm gonna watch this VODs. It is kind of awkward because I'm not sure if I should even like try, since obviously no one's watching. But I'm hoping that some people, well, one, I'm hoping some people do come to join the live stream, but two, I'm hoping some people do watch the VOD, because I think it is kind of fun to see like the full thing, but most probably this will be edited into a video. Yeah. I'm not gonna talk about it because no one's here, and if someone's watching the VOD, they do not want to hear that. Okay, so let's get back to the scanner. So we'll get back to this list, but know that it's here. Struct scanner, and okay, so our scanners in needs to store a few like sort of flags, right? No, the locks. Sorry, no, nothing. I said nothing. Okay. So let's just start off with just source. Right, that's just the source code, the string, and what this does is in Rust you have data and behavior separate, so you have to add behavior with an info, and you can do like info you can implement interfaces. You can do info copy for scanner. This can implement the copy trait, and can add behavior for the copy trait here. Okay. They call it traits, but like if you don't know Rust, then you're not gonna understand what traits are. Let's just say interface, right? Right. Okay. I don't know. Yeah. Okay, whatever. I'm gonna try that later. That's embarrassing. Right, so we'll start with a new function first. This is some very basic stuff. Right. Source. So we're gonna get the source string here, and I think I can just do this, right? Yeah. Awesome. And also we're gonna start off with another thing, tokens, and that's gonna be, oh, we have to actually add the token type, right? gonna do that for now. And do that. Yeah, it's a vector. Copy that out as well. Right. It's gonna be public. Okay. So now let's make our token types. And
please tell me you have the package.
I would.
okay.
If somebody was a little less aggressive. Hey, stop! I said stop!
Okay. Little Valorant ad for some reason. Okay. Right, what are we doing? Dude, I keep forgetting. If you've noticed, like every once in a while, I'll just do for like 5 seconds. I'll get back to being like so fast. I forget what's happening. Okay. Okay, so I'm gonna create a scanner folder here. What's that? Oh god, what did I do? Oops, trash. Folder. Scanner. Move scanner into there. Move. And rename. Mod.rs. Okay, so what that does is basically says that in this folder is the module scanner, and this is like the head of the module. So if you do mod scanner here, it will get this mod.rs, and whatever this mod.rs imports will go to this mod scanner here, like as like a scope resolution thing, right? But this stuff will like go directly into there. You'll see what I'm talking about in a second. Right. So that's accessible from there now, and now I need to create in here a new file called token.rs, and I'm gonna do a quick mod token. That does work. Okay. So first what we need is an enum for our token types. So tokens are basically just like data representations of like all the words in a language. So like this here, public, that's a token, right? That's one token. That whole thing. That's one token. It has the value probably like pub, right? Something like that in an enum in the Rust compiler. And basically, so then when you're going through all the tokens, like say I have x plus y, right? There's an x token, there's an identifier token, there's a plus token, there's a plus token here, since Rust has that implemented in the language itself, not as functions as compared to Yoast. And then there's a y, there's an identifier token over here. So so when the parser is going through all the tokens, so the scanner first takes a string, which is characters, turns it into a list of tokens, right? So let's say this was just the whole code that we sent to our compiler, and it'll make 3 tokens out of this: identifier token, plus token, identifier token. So then when the parser, I believe it's the parser, when the parser is going through all the tokens and turning them into a struct, a sort of tree, it's called an abstract syntax tree. That's basically just all of our code in a tree, like represented as like a structure. You know what I mean? Okay, whatever. Like it makes sense. Okay. A code represented as like the whole of the code represented as a structure, as expressions that have their own values, and then they're like a part of another expression and whatever. Basically, like it goes through these, and like each token, since it's doesn't have to like go like check the actual string value, it knows, oh, okay, so we have an identifier here with the and its value is y, so I'm gonna check if y has been defined yet, and if it has, then I'm gonna use that value here in my abstract syntax tree. That's gonna be expression I use. We'll see that more later, but that's really it. So now we're at tokens. I'm gonna do that real quick, and obstruct token. Right, and mod token use token type done. And then we can do this. Yeah. Okay. So now we go back to here. These are all the tokens that we need. Even though these are all the tokens that we need to store as tokens, but these will be just scanned differently. These will be scanned. Yeah, these groups will be scanned differently, basically, but they're stored in here as just tokens. So I think I kept somewhat of an order, but really there's not much of an order. And the source that I like used to learn had it was pretty like organized in this regard, unlike me. Like it had like groups of token types, but I'm not gonna do that. I'm lazy. So let's just start. We have our semicolon. Right. We have our new line. So the thing with languages, I want new lines to be, or sorry, semicolons to be optional. It's kind of like JavaScript. You might not actually know that JavaScript does this, but basically JavaScript allows you to not use new lines, but it prefers any case over the case that the new line is a semicolon. It's like kind of criticized. A lot of people say that's like really stupid. I've made a post on Reddit asking why that's stupid on a programming language separate, and I'm genuinely curious. If you know, please tell me. I think like I see that it can cause some weird errors. Like for the most part, you'll be like pretty comfortable. Just not using semicolons. You might have to throw it in. It'll look kind of ugly, but it's like whatever. Like it's one character, you know. And I don't want to create a whole system of guessing whether the new line is an implicit semicolon or not, because I don't want to be the one that defines what syntax you use. I don't want to be the one that says, okay, so making like a function like this, that's fine. You can put that on different lines, but you can't like make the function arguments on different lines, or you can't like do this. What if someone wants to do that? What if they want to do that? I shouldn't be the one that I can tell them no. And so this is like the best option, I think, for me. Um, for like what I'm going for, you know. Yeah, so that's why we're starting new lines. I actually don't know if I will need to store them, like how I wanna do it exactly. I'm not sure. But I'm just storing them for now, and we'll see when we get to the parsing bit. Okay, and then we have colon, comma, colon for, I believe, variable declaration, and I believe just variable declaration for declaring the type of variable. A comma for as a separator in compound types. Like this is, you know, compound type, maybe parentheses. Like, see, like there's a comma there. It's not a comma there because it's trailing comma is unnecessary. But there's a comma there. See, as a separator. I might replace this with a semicolon later, just to like make it so there's one less reserved. There's one less reserved symbol. But I don't know. We'll see. So we have the comma, and we have the hash. Should I call it a hash? I think you call it a hash. Yeah. Hash tilde. Hash is for like turning code into data. Like if you have a function, if you just like put the function and they're just like that without the hash, just gonna call the function right there. But you put the hash, it gets the data representation of that function. So now you have that data stored here, and you can call that anywhere else. Okay, kind of cool. Hash tilde is for destruction. Same as C++, I believe, but it's also a destruction operator. It isn't just for defining a destructor. Should I even have that? I should probably mute my file meaning. Just 1 second. Okay. So what I could do, okay, let's not put the tilde in just yet. Do that for now. And think about that, because what I could do is just have that as a method. So you have a variable x. Let's do that. Do that to delete it, and then you can implement some interface to get that function first off, right? To get the function in your type, so you can like control destruction. But the thing with that is, you'll need a default destructor, right? You'll need a default destructor, because like you shouldn't be expected to create a destructor for everything, every structure you make. So it needs to be a default destructor. But there also needs to, but the object also needs to know when it's being destructed and be able to react to that. So like my options here are either I make it so it's a method and there's just an implicitly a method in every struct, just implicitly thrown in there, and I don't know how I feel about that. It would be like since it is a method, it would be static, so it wouldn't affect memory consumption. I would most probably just go and call some function that's like only defined in one place, like or a correlate function maybe. Okay, yeah, okay, that's fine. And we're doing this into the correlate. Don't need it as a reserve symbol. Oh, and then what I can also do, but that creates a lot of weirdness. It's not too bad, but no. I have a very similar dilemma with the equals sign, but I'm gonna leave it as it is for now. Yeah, and I'm gonna actually add some grouping here. Serve symbols. Serve identifiers. I think I explained the difference between these two pretty clearly. Sorry if I didn't. Feel free to ask any questions. Yeah, ask questions if you have any. Oh god, where was the donut? Okay, the hash, okay. So that's the dot and the double quote. Like that's actually, I don't think I need to store the double quote because that's just gonna get eaten up in string literals. So that's fine. Yeah, car literal as well. Function signature and the pipe for the function signature. Okay. This thing here. Function signature. And of course I need the braces and the parentheses. What did they call it? Left bracket. I'm gonna now into reserved identifiers. So we equal and then slash slash equal slash slash okay, what do I call that? I'm gonna pass that for now. That's called an at, right? Called an at, right? But you say You say at when you're like at gmail.com, you know. I don't know if the character itself is called an at. That's kind of a weird name, so I'm not sure. 1% and dollar. So dollar sign or just dollar? Dollar. Yeah. What the hell should I call this? Minus grid. I guess. I don't know. Yeah, sure. I guess. Oh, I just passed the hour mark. I think for being live. Awesome. Tired though. I slept at like slept really late and woke up at like 8 a.m. I haven't sat in this room since then. Okay. The at sign, normally read aloud as at, is also commonly called the at symbol, commercial at, address sign. Oh, the absence of a single English word for symbols prompts some writers use the French arrow base or Spanish and Portuguese arroba. Particular new words such as ampersand. Ampersand. Aspirin. The hell? Strudel. That sounds fine. Term alpha sand. Okay. I'll just do at whatever. Sure. I was reading the Wikipedia, by the way. Okay. Is that it? I think that's it. Okay. Right, that's all our token types. I'm gonna deal with the tilde later because it has consequences for the assignment operator. Because if I'm like setting a precedent that implicitly adding a function, implicitly adding a method, a field, a data field to a struct is alright. If I'm setting that precedent, then implicitly adding the assignment operator as a field might happen, but it's more complicated than the tilde though, so I'm not gonna think about that. Now I'm just gonna remove that. Okay. So now we get to the actual token struct, which stores. 1 second. Yeah. I'm gonna do some quick derives here. Don't worry about what this is if you don't know. It does not matter. Derive. Control C. Right. Literals. Forgot about those. These two guys, right? They're just these two. Okay. Um. Hmm. Okay. I'm gonna quickly change it the structure of this real quick. And rules. So of course we need our. Okay, so how we're gonna do this is use Rust's arithmetic types. So I'm gonna do that, and I'm gonna make another enum. That'll be enum literal, right? Literal. Yeah. Oh, gotta do that. Right. About one. And so basically, these all just need to just know that it's this symbol, or it's this character, or it's this identifier, or whatever. Oh god. Right. But with literals, you need to also know the value. Probably name this well. Nah, I'm just gonna. And so here what we can do is a string literal that stores a string, an integer literal that stores let me check. Okay, so 932. And then float literal that stores 32. Okay, so these are all the literals that we have. We also have function literals, but we don't need to store them like this. We parse them later on. So the identifier there. For identifiers, like a non-reserved identifier, like a variable, you know what I mean. Anyways, I think we're good on that then. Now we get to the token struct. Now the token struct, what it stores is, first of all, obviously, so the type of the token. Type. Then it stores the lexeme. Now, what is the lexeme? I hear you asking. It is basically like the string that the token comes from. So for a left brace token, this would be the lexeme, right? That character in a string. That would be the lexeme. And for like a // that would be lexeme for a // just the thingy as this is the string that the token comes from. I'm actually still not sure what it's used for further on in the compiler system, but I do know that it is necessary, so I'm not gonna remove it. Include right. Yep. Like this. Okay, let's add an implementation for that. Token actually. Thank you. First, gonna make a new function. just a little constructor. But isn't like officially a constructor. It's just a normal function, but yeah, constructor. Rust doesn't have like actual constructors. You're gonna have to call this function to get this quote unquote constructor, you know. I believe you just, yeah, I believe it's just this. Yeah. Data vaccine and then line. Yeah. Right? Did I need to do anything? No, okay. There's a toString function here, but I don't know what I need that for. I'm not. I think it's just for printing it later on. I mean, I guess I'll implement it, but this isn't really like part of the important stuff, but it's just there, so it's probably gonna get removed later on because it's useless. Well, it's gonna be pretty useless after we're done wanting to print our tokens out, and instead I want to actually like parse them, you know. Okay. Okay, so we have our tokens, so now what we can do, good again? No, good again. Now what I can do, I should probably push this all this stuff here. Alright, so, okay, this is where the real fun stuff happens. Finally we're getting to vehicle scanner, freaking hour and 20 minutes later. Okay. So, we need to store a few quick variables for our scanner. And that's initialized to 0, that's initialized 0, that's initialized to 1. Okay. It's really relevant in a second. And so the basic, okay, let's first make a function for scanning all the tokens. You know, this is what you're gonna call, this is what you're gonna call to like start scanning tokens. And it'll return nothing for now. But it's gonna need to return an error later on. Oh, actually no, it's it's gonna return something right now. It's gonna be a result, and it's not a standard error. It's a normal result. Okay, so we like like token if like all goes well, right? And if we get an error, but now it's gonna return nothing. Okay, so that's gonna be an error for all. Don't worry about it. But it will return some error message later, and we will need to make some error reporting code for it. Okay. So first, we get our character. So it's gonna be from self dot advanced. So we're gonna need an advanced function. So what the advanced function is gonna do is the advanced function is gonna do. Wait, what? What? By the way, is that not work? Oh. There. The advanced function is gonna increment our these thingies, right? Increment these thingies, and it's gonna go through the source, and we're gonna go through like we're gonna consume characters one by one from the source code. So let me show you. So the current variable, what this does is that's the current position that we're at for the token that we are scanning. Start is the character that the token that we're scanning right now started at, right? They're the first character of the token. This is where we're at in scanning the token. For single character tokens, start and current is gonna stay same for the whole time, right? But for multi-character tokens, current will be a little bit further ahead, and you'll see that when we get there. So advanced, just do self dot current plus equals to 1. So current starts off. These both start off at 0. Maybe we should start off as -1, so that what we can do is like use this directly to do things. It's gonna. Oh, it's U size though. Is I size a thing? Does that exist? That does exist. Wait, sure. Why the hell not? Because this is thing that I'm doing. So why we have to do it as -1 is because we're like for the first character we're doing advanced. Oh, completely unnecessary. So we can do here, instead of ring advance, yeah, well, we're gonna implement this real quick first. It's gonna increment, and then what it's gonna do is this, and return self.source.cars. So our source string, right? It's gonna get that. It has a list of characters. Oh, we should probably do here. What does cars return? Damn. I should do here instead of even storing the string at all. Even though we do need to store the string down. Or we can do here. What we can do here is source cars, source dot cars. It's an iterator. Okay. Okay, what's this type then? Let's use simple. Okay. That work? That works. Okay, what scope is it in then? Core string. Okay. Use core string for string bars. Okay. Oh, god damn it. Ah, god. Okay, how do I have to add a lifetime specifier? Oh, Jesus, man. I hate lifetimes so much. Oh, they're so annoying. Okay, what do I have to do with this? Let's add some slight bit of efficiency. Come on, man. Can I just do iterator? Can I just do iterator? Does that work? Okay. Box iterator.
Scully Music, Season 1.
Oh my god. Go away. There you go. Iterator. I believe Adam's car, right? Okay. How do I specify these? Oh, what's it called? Item? Item equals car. Okay. Now, does that work? Mismatch types. Search mismatch types. Expected found. Dot boxed. No, box. from, I believe. Box new. That work? It does work. Oh, that was that was way too much effort for barely anything. Jesus. This means I only have to call cards once. That increases efficiency slightly. And then self-current -1. And do I have to do -1? I don't think so. So my idea is for this first thing, right? We do just this that, right? And what it does is so the first character is gets the 0th one. So then when you call advance on the next characters, you like then it's gonna, for the second character you're gonna call advance, and it's gonna get the first like index, right? Instructions here obviously knows this, but like, isn't that genius? It's not genius, but like it's much better solution than what the original had, I think, in my opinion. Whatever, it's nice. Okay, I like it. Let me enjoy good things. Okay, so then we do the next, the rest of the, advanced, yeah, advanced is done. So we can advance characters. So then let's do the rest of scan tokens. Oh wait, I put this in the wrong freaking thing. Oh no. Ah, no, that's unfortunate, because yeah, I did all that work for absolutely nothing. Yeah. Okay, yep. Actually, this is way too complicated. I could have just. Oh, so smart. Oh wait. Okay. Let's see. Cool. That. Actually, I'm just gonna go with it. Whatever. I hate it, but whatever. The alternatives, all the alternatives, do not work or just are dumber. So whatever. And this doesn't even need to be here. So while not, self dot is end. Something that we're gonna need to implement. Do we need to do that? Maybe. And so then go here, fn at end self. Oh, why does that work? Wait, it should need for it to be mutable. I don't know why that works. Whatever. There's a boolean. Right. End and just checks. How to do it? I believe self dot current greater than or equal to self dot source dot length. Well, not self dot is end. I believe it's current. I don't think it's start because current would make sense because you need to use this in the middle of a token as well, I think. So yeah. Well, that is self dot is at end. We self dot start equals to self dot current, right? And then self dot and token singular. Okay, so one thing I am gonna do change that I am gonna change not yet in a second is this is gonna be gone. That's gonna be gone in a second. Not yet though. I'm gonna get a little bit further on and then I can like make sure that it's actually a good idea. So yeah, what we're doing here is basically every time this loop runs, it means token has finished scanning. And so it should like update this. And I would it be stupid to put this at the end of scan token? Like it's the same thing, right? It changes when this is called in the order. Goes check, set, and scan. I'll go check, scan, and set. But is that end depend? Does not depend on start. It's current. It does not change. Okay, I can put it right there. It's fine. Oh, there's not a good reason to put it at the start. I'm gonna quickly just do this because this is bugging me. Okay. Okay. That's gonna probably change anyway, so it doesn't really matter. Yeah. Okay. I think what I'm gonna do is yeah, I'm gonna take a break for a second, and then I'll be back. I don't think the watch should be messed up for this. I think it's just cut to the right thing. I really hope. Yeah, I'm just gonna take a quick break. I'll be right back. I made sure that there aren't any viewers right now, so it should be fine. Okay. Except that apparently one viewer, I'm not sure that that's just me or something that actually exists, but Sure, I'll just continue where I don't need a break. Okay. So what we're doing here is making a scanner for a pilot. So basically, what the scanner does is it goes through like a string source code and enters into a bunch of a list of tokens. So like what we're doing here is storing. We have this struct called scanner. Languages first, by the way, and start the source string, and using these functions to go through the string and get tokens into this token vector. So make sure we're not at the end yet, right? And then we're scanning token stuff, right? Okay. Oh, went scan token. Oh, that's it. Okay, there you go. Thank God it actually didn't the error.